Good. Excellent. Over to William.
All right, thanks for the intro, Chris. So my talk is titled An Event-Based Architecture with Clojure and Kafka. We've kind of heard a few things today in particular about doing an event-based architecture, so it's good that some of you are already familiar with this. I'll explain what we're doing at Funding Circle and what we're doing with Clojure in particular. So an event-based architecture is actually a really powerful and compelling option for doing a microservice-based architecture. It can stop these sort of traditional woes we get into where all of our software becomes very interdependent, very, very tangled up. And what it really does is puts data first, which is most important for a lot of companies and the Funding Circle as well. So my name, as already introduced, is Will Hamilton. I work for a company called Funding Circle. Hopefully a few of you have stopped by the booth downstairs. And this talk's going to explain a little bit about what we're doing. So there's sort of two main themes for the talk. There's process. How do we actually take a large development team and shift them to a different language? And there's technology, explaining why we've used Clojure for this architecture. So I'll explain a little bit about what Funding Circle do first, so you can explain where we're coming from. So Funding Circle was founded 5 years ago in the depths of the credit crunch. And the mission of Funding Circle is to connect investors who are looking for a return on their savings with borrowers who are looking for a loan. And we consider ourselves a financial technology company, and we think technology is actually one of the things that's really going to help drive our business forward and see us defeat all of our competitors. So let's talk about what our tech stack used to look like. We started out with a monolith, which I think pretty much everybody does. It makes sense. When you start with a new system, that's the time you actually have the least amount of information about what you're going to do. So it's probably the wrong time to decide what sort of different systems you might need. So we started with a monolith. It was written originally in PHP, which I think is probably the dirty secret behind a lot of startups in London. It was swiftly rewritten in Ruby. So we became actually quite a really big Ruby shop at actually a really great time for Ruby. The ecosphere was really vibrant. There was a lot of great Ruby developers out there, and we were able to build and grow as a business. And we got to a point with sort of about 60 developers. And now I joined Funding Circle at a time in its technological life cycle that I'm sure a lot of you are familiar with. It's the point at which the monolith starts to really kind of break down, and you move to more of a service-orientated architecture where you start to split things up into different services. And this worked pretty well at Funding Circle. We managed to start splitting out, bits and pieces. We've split out our accounting system, our company lookup system, large parts of our front end. And we did pretty much all of this in Ruby. So that was basically fine. What sort of happened during this year is there began to be sort of a general desire within the company to try and do something a little bit different. There were some frustrations that we were sort of officially within the company restricted to doing Ruby. A lot of our internal tech talks started to be focused on different languages. We started to have people running dojos on Elixir and Rust and Clojure. And there was a little frustration that it felt like we were using Ruby for everything, regardless of whether it was the best tool for the job. So we started thinking about maybe using a different language or something. So there are a few questions there. Obviously, you have to choose which language do you use. So people had different favorites. And we had to look at actually how to introduce a new language. So one option we looked at was, okay, we're using an SOA. Let's take the next service that's kind of due to be written and write that in another language. We ruled that out. We were a bit worried about what would happen if we did that for a few different reasons. We were worried that we would write this one app in a new language, and it would be a special snowflake that nobody would be able to look after. We couldn't decide which language to use, and we weren't really convinced that the next app that happened to be off the rank was actually a particularly good use case for any one language over another. You couldn't make the case for doing something other than Ruby. So we didn't do it. Now, obviously I'm here today. We're doing Clojure. What changed? What changed is we decided to remodel our entire architecture. So the old system of an SOA, it was kind of creaking a little bit. we'd had some of the problems I've talked about before. So we decided, we really needed to do something different. We needed to do something that would help tackle our technical debt and also allow us to continue providing new features, because the business, fortunately, didn't stop growing. So we needed a new vision for the future. What was that vision? It was logs. So there's a few good talks already about this kind of architecture, and I'll throw a few links in at the end. So I won't dwell too much on it because it's not the core part of this talk. But broadly, what you can do with a log-based sort of architecture is get around some of the problems that you can have with a traditional SOA. So if we look at what a traditional SOA might look like, what you end up with is a lot of apps that were all written for good intentions, and they all pretty much end up talking to each other. What's actually going on here most of the time is you're doing dual writes. So if you have a look at Web Server 2, something's happened in your system, maybe a customer's registered, maybe a loan's been given out. What you do is you record that in one place, probably your operational database, and then you start to add things and you start recording it elsewhere. And you tend to fire all of that off from one app. It's dual writes. You put it in your cache, you put it in your other cache, you put it in your data warehouse, whatever. It starts to get very, very entangled. So the idea of the log-based system is to say, okay, ignore all that complexity and actually really look at what's happening in your application. So at the heart of it, what's happening in your application is you're dealing with events. Something's happening in your system, and then other things happened. It sounds very simple when you put it like that. You can abstract things away in your system to be more closely aligned to that model. These are some of the strains I've talked about. One of the things that's particularly important actually for Funding Circle is that if we have a lot of different applications that are working on things, all of the data becomes locked away. We have a lot of services that have their own database, and it's an operational database. It's there to be used for the business logic. And at Funding Circle we have quite a big sophisticated data analysis team. So one of the things that's important for us is analysing the creditworthiness of borrowers. So we want to make sure that they're viable to give a loan to. So we've got all these guys that have got PhDs, and they're trying to do data analysis on the little Rails apps that we've written. And these databases we've put together just aren't really fit for that. So events are the answer. Events are great because they're logical. A business event happened. What happened? Can you describe it? Now, coming from an OO background, OO has always been very, very good for me because I think it forces you to think about what sort of objects you've got in your system. So I've always liked to chat a lot with my product owner, and I say, what would you call this? What kind of things do you think are actually happening in our system? And events are a kind of great addition to that. They force you to talk to your product owner, and you say, what do you think's happening? How would you describe that? What sort of terms would you use? And you start to really build out a great model of what your apps, what your whole system is actually doing. So there's a few things that might look a bit Clojure-y already. Events are immutable. They happened. They definitely happened. They're not going to change. If something else changes later, it's another event. Events are quite naturally shareable. If just because an event happened doesn't mean that it has to be constricted to one place. You can share that event across different systems. And events are data. The actual thing happening is what you're interested in. That is your data. It's not what's in your web apps database. So this is an idealized view of what the previous system might end up looking like. You'll have the commit log in the middle, which is just a sequence of records, what happened from pretty much the start of time in your app. And you produce events, so these can come from various places. They all go to the centralized log, and then you hang consumers off that do something based on what happened. So specifically for us, the commit log is Kafka. That's what Kafka's really good for. It's actually a really sort of centralized, persistent data store. Really, it's actually our prime source of data. So we kind of constructed this new vision for what we would do at Funding Circle with our architecture, and it was a good occasion to kind of look again at our choice of language. We were all pretty happy with Ruby, but given this new architecture, what made sense? So, kind of what you'll all ask is probably why Clojure? There's a few reasons. This isn't exhaustive, but there's some reasons that this fit pretty well with our new architecture. Immutability. So Clojure really puts immutability first. It's kind of the default. The whole community is really in love with immutability. So this fits our architecture pretty well. We've already talked, events are immutable. They come in, they come to a system, maybe you change it and you spit out another event. Clojure values simplicity. So as a sort of fairly large development team at Funding Circle, simplicity is actually even more important than it is in a smaller team. It's really a culture that we want to inculcate. We want everything that we do to be very simple. And since we're going down a microservice architecture, each of our microservices is going to be pretty plain, do one or two things. I wanted to include a quote from Rich Hickey, since that seems pretty standard. I couldn't find the one I'm sure he said. He's definitely said something like this, which is if you have simple things, you just have a lot of things. And that's actually fine. It doesn't matter if you have a lot of things if they're all simple. If you have a few complicated things, that's horrible. If you had a lot of simple things, you probably don't even need to worry about a lot of them. So this fits a microservice architecture actually pretty well. And we've only been going a few months with this new architecture. We've actually managed to write about 20 apps so far. But it's fine. They're all simple. Concurrency. So the event log in the kind of center of our system is basically a stream. So you hook up to it, events come out. There's no reason really not to do concurrency a lot of the time for this. If you're worried about ordering, concurrency's a bit of a nightmare. If you're not, then you might as well just sort of hook everything up and stream it straight the way through. So Clojure's great for this. Clojure makes it actually so easy to do concurrent code that you might as well. It's kind of worth pointing out this is sort of still a matter for some debate actually internally. Concurrency does have some downsides in that it kind of obfuscates a little bit actually what your apps are doing. So we talked about transforming from maybe A to B to C to D. With too much concurrency, you hide a lot of that and you have something that's turning C to D and you're not quite sure where it is. So we're going to keep an eye on this, but it's really nice. It's really nice with Clojure that we can do this pretty easily. Okay, so let's talk a bit more detail about how we actually do this. So we're using Clojure, we're using Kafka. What does that look like? So Kafka's written in Java, so there's a sort of native Java API for this, and there is a Clojure API as well called CLJ Kafka, and that's mostly okay. It gets the job done. We weren't really too keen on the interface that it provided. So I've said already that Kafka's essentially a stream giving you stuff. Why not make the abstraction more stream-like? So we wrote a little wrapper around CLJ Kafka. It's called tube lines, and what we've done is we've used a small library called Manifold. So what Manifold gives you is exactly that. It gives you streams. So this is the only piece of code in this talk. So if you wanted more code, I'm sorry about that, but this is it. What tube lines gives us is a very easy way to interact with Kafka. We have a producer and we have a consumer, and you get a stream, and you can put things onto it and take things off. So this works really well. It's great for testing as well. We don't need to use Kafka. We just give it a stream that we're totally in control of in our tests. We put things onto it. We take things off. Another important piece of tech is the Schema Registry. So events are really important in this system. So the format of your events is really important. You don't want to be putting events onto your log that you haven't actually thought about what they should look like. So what you can do is you can enforce actually what each particular event looks like with a schema. So we use a technology called Avro, where you basically write JSON. It hooks up to Kafka, it hooks up to tube lines, and it makes sure that when you publish an event, that's actually really what you're interested in seeing. So going back to OO, with OO, you particularly think of what your model should look like. With this event-based architecture, you really think seriously about what your event should look like. This is a little example of how all that fits together. So we have our Avro schemas in a repository. We can look after those, check that they're okay. We get them in. They go up to the Schema Registry through CI. And then when TubeLines looks to publish something, it will check in the Schema Registry, make sure it's okay. And if it's not going to publish it. So if we take a step back from the technology and talk about process again, what's this been like for us as a company moving from Ruby? The answer is it's been pretty interesting. We really wanted to make sure that we did this transition properly. So I mentioned before we already sort of rejected one path into doing Clojure, and that was because we were really worried that we wouldn't get it quite right, that we wouldn't be able to take the team with us. So having this new architecture really helped, that we could actually make a genuine case for using Clojure. But what we actually did in detail is we took a team and we sent them away to do some prototyping. So we said, this is the vision for the future. Can you please go away, spend a few weeks on it, see if it actually all holds together. So we sent them away to write some Clojure, some Kafka, everything local, no infrastructure, and they reported back to the wider team with how things had gone. So what this really helped us do is actually build up confidence within the team that we were making the right choices, that we could really sell Clojure to the rest of the company, and that worked pretty well. I think a few of the things we've heard today are kind of about whether maybe Clojure is too off-putting at times. I mean, Ali's talk previously was quite interesting on that front. And what we did is we were quite conscious of this. We didn't want to take, the best programmers from the team and they would go away and they'd be special people who write Clojure. We took entire teams and we converted them. So we took juniors, we took mid-level developers, we took seniors, and we said, you're all intelligent people. You should be able to go away and write Clojure. And it's gone okay. So there's a few things we've done to really help with that process. We've read a lot. Read a lot of books. These are probably our two favourite: Clojure for the Brave and True and The Joy of Clojure, both great books. We've done a lot of pairing. We're always pretty big on pairing at Funding Circle, but we've kind of doubled down on it with the Clojure work we've been doing. And we've done a lot of internal talks. So we've tried to share with the rest of the company that there's still a lot of people doing Ruby, and we want to make sure that they're really involved in everything. So we've talked a lot. We like the sort of Spotify Guild framework, so we have that. That's completely open for anybody in the company to come to. So where are we now? I've started this when I joined, since that's the most important time. So back in October 2013, we were 12 Ruby developers. We kind of ballooned to 47 earlier this year, and the point at which the Clojure bubble starts to expand is when we started to do our prototyping. So we took a team of 7, sent them away, and since it worked okay, we're kind of gradually expanding what we're doing with Clojure. So what we did initially is we actually identified a sort of fresh area of the business that we could look at originally. We wanted something that wasn't customer facing, so if we messed things up, it wouldn't be too bad. And we wanted something without any UI, since it's really hard to decide what UI to use with Clojure. So the idea is we're gradually going to expand this Clojure bubble actually as we transition everything to our new architecture to kind of encompass the entire company, really. So I'm really interested in this, and I've been asking around a bit. So we'll do a bit of audience participation again. Can you put your hands up if you're doing Clojure as a day job? Okay. Can you keep them up if you've got a team of 5 or more? 10? 15? Okay. Funding Circle people should probably put their hands down. So from asking around, it seems like Mixed Radio have a really big team, but we're slowly going to increase to eclipse them, hopefully. So you should see Funding Circle hopefully more and more at Clojure events, and we're going to try and do more open source stuff. So look out for TubeLines as well. I wanted to finish up with just some thoughts about how this process has been actually transitioning from Ruby, transitioning to a new architecture. We kind of did everything all at once, really. We switched language, we switched our entire infrastructure, and there's a really interesting talk you could definitely do just about our infrastructure stack. And we even did a data migration at the same time, which probably was a bad idea. But I think it is quite important to, if you're going to try and shift your company to try and do a different language, you kind of need to go all in. I think it can't be a thing where you just write one service in a particular app. It's not gonna take hold. You need to make a really actually big commitment to try and identify how to do this as a company and really go for it. Coming from Ruby, there's a few things that are pretty interesting in Clojure. I think we all wanted to try and do something functional to see if it, the famous sort of change in mindset, and that's pretty much happening. I think there's some things that we kind of miss from Ruby. The emphasis on testing isn't quite there in Clojure. There's some decent libraries to do it, but it's not kind of ingrained in the way that it is in Ruby. So we struggle with that. And the big thing for me trying to lead a team to do this is that it's kind of reset a lot of the knowledge that we had in the company. We were pretty settled on some of our patterns, the way we were writing apps. We kind of roughly knew what was a good idea on how to do something in Ruby. And in Clojure, we got over the initial hump of, how do I do this in Clojure? I think we're past that now, and we're starting to have these discussions that are more based around, the structure of an app. What does that actually look like? And it feels like in Clojure, for good or bad, that's not quite sort of settled yet. There's sort of competing frameworks out there. There's a lot of different ways of doing things. So we're slowly sort of converging on, internal best practice, which I think happens at most places. But in short, it's working out pretty well. Thank you. Any questions?
So you've used Kafka for event sourcing. Do you use still databases on the back of your microservices, or is it just purely Kafka?
We do use databases. So what typically happens is an event happens, some microservice picks it up, and it might not be, for example, ready to do something with it yet. It might need to wait for something. It might need to interrogate something else. So very often we find that a microservice still needs a small operational database. That's okay, because it's actually just for that app. You avoid the problem of having a view, for example, needing to read something from that app, and you avoid the problem of your data team needing to read something from it. It's just a very, very internal thing.
I was wondering, in your transition to Clojure, whether you've had a high turnover of staff, or whether you've kept everyone's jumped on board the Clojure bandwagon.
So we took a team originally and basically converted them to Clojure. I don't want to say forcibly, but but that's what we did. And then we're kind of gradually taking on other teams. And what's kind of happening is the people that in the company that really want to do Clojure are putting their hand up and saying, "Can I join that team, please?" And it's worked pretty well for recruitment as well. We're actually getting people who, when they come and interview with us, we say, we're looking at doing Clojure. They say, "Amazing, can I join?" And we've even achieved the really difficult feat in London, which is converting contractors to full-time. Does that answer the question?
So you mentioned you sent one team away to kind of do some Clojure and see their feelings. Like, did you try it out with any other languages, and how did it compare? And
we didn't really. People in their own time were trying out different languages, and we really reached a point where we kind of had to make a decision. And it's difficult. A lot of people within the company will say, "Why Clojure?" And it's always quite hard, I find, to actually put the case for one programming language over another. I've tried to do that today, but you could still make pretty good arguments for any other language, any other language over that. So the idea of the prototyping stage was to say, okay, let's try Clojure, let's see if it's the right tool for the job, and it kind of is. All good? Thank you.